We're trying to factor these three polynomials, and if you look at the questions closely, you'll see that all of these have some common number. So first, let's try this one. See, 42 and 63 are all multiples of 7. If you remember the times table for 7, these do appear in the times table for 7. So that means you can factor the 7 out. Now if you factor the 7 out, what you get is x squared. 7 times 6 is 42, so 6x. And then 7 times 9 is 63, so you get this. Okay, now you have to factor x squared plus 6x plus 9. And since x squared has coefficient 1 in this case, that's a lot easier to factor than the other case when you have something that's not 1. Okay, so that's what we will do in the next example B, but here it's easier. The reason I say it's easier is you just need to find two numbers that multiply to 9 and add to 6, which are 3 and 3. So 3 times 3 gives you 9, and 3 plus 3 gives you 6. So if you notice that, then what you have is you now have 7 times x plus 3, x plus 3, okay? Yeah, which is same thing as 7 times x plus 3 squared. Now, whenever you do a factoring question, be sure to check your work, because you know in the exam, small mistakes can add up, and you may end up losing a lot of points because of mistakes. So let's actually do the check. 7x plus 3 squared, what is that? That's 7 times x plus 3 times x plus 3, which is FOIL, right? First, outer, inner, last. So this is x times x, which is x squared. X times 3 is 3x. 3 times x, that's 3x. And then 3 times 3 is 9. And indeed, 3x and 3x, these are like terms, so you can add them, which is 6x. So we do get this one. And then finally, if you multiply the 7, if you distribute the 7 to each terms, then you end up with 7x squared plus 7 times 6 is 42x. 7 times 9 is 63. Okay? So that's how you do a check, and be sure to check it. Okay? For the next two examples, I wouldn't do the check to save you time, but please try to check my work. And you know, in case if I've made a mistake, please let me know so I can change this video. Okay, 12x squared plus 2x minus 4. Well, I see that all of these are even numbers, so I'm going to factor the 2 out. 12 is 2 times 6. 2x is just x times 2, and then negative 4 is now negative 2 times 2. Okay, now this one is more challenging than the first one because the coefficient of x squared is not 1. In this case, what you do is you have to first multiply the first and last. So 6 times negative 2 is equal to negative 12. So you get negative 12, and then this is really 1 times x, right? So you also have 1 as two numbers, and we're looking for two numbers that add to the middle number and multiply to be the number that you obtained by multiplying the first and last. Okay? Alright, so what are these two numbers whose multiple is negative 12 and their sum is 1? Well, because it's a negative number, it must be a negative times a positive, and I can see that 12 is like 4 times 3, or 6 times 2, or 12 times 1. And one of them has to be negative, so this addition is like really a minus. So which one subtract to 1? I see that 4 minus 3 is 1, right? So after considering this, we can see that this has the following solution. 4 plus negative 3 equals to 1, and 4 times negative 3 is negative 12. So you get 4 and negative 3. What do you do with it? Yeah, this is much more complicated, and actually there's a lot of steps involved in this. So you should definitely do more problems using such a thing. Just this one example is probably not enough for you, okay? So let's just say this is step 1, and this is step 2, and now step 3, what do? You do something called factor by grouping, which is you take this middle number 1. So what you do is you take 6x squared. Instead of writing 1x, you use the two numbers that we figured out, 4 and negative 3, right? So you write it as 4x minus 3x minus 2. And the reason you want to do this is now you can factor the first two and factor the second two, and that's why it's called factor by grouping. You group the first two and factor, you group the second two and factor. And what that gives you is that you get 2 times 6x and 6x squared and 4x. They both have x in there, and they both have 2 as the common factor. So I can factor the 2x out, and that's 3x plus 2. On the other hand, negative 3x and negative 2 really doesn't have any factor except for negative 1. Whenever you have a minus in front of x, you should also factor that out. So it's minus 1 times 3x minus 2. And because now you see that there's 3x minus 2 and 3x minus plus 2, sorry, that should be plus 2 because they're both minus. Because they both have 3x minus 3x plus 2 as a common factor, you can factor the 3x plus 2 out, and the result is you're left with 2x minus 1 and 3x plus 2 multiplied. So this is the factor for B. Okay. Again, please take time to expand this to check that this indeed is equal to that. Okay, the last one. Now this one, unfortunately, well, I still see that there's some common factor between the two. Let's see, I see that they're both even, so I can factor the 2 out. So 12s squared t squared minus 27u squared. Okay, so that's what you get after factoring the 2 out. But I still see that 12 and 27 are both divisible by 3, right? So I'm going to factor 3 out again, which is 4s squared t squared minus 9u squared. And 2 times 3 is 6. And then we are stuck. I don't see that anything you can do with this except you see so many squares. Sometimes this comes in the form of fourth power or whatever. If you see squares, you have to use the difference of squares to factor it. So a squared minus b squared, how do you factor this? It's a minus b times a plus b. Okay, so we want to make use of difference of two squares formula, also called difference of two squares dots formula. And first rewrite this as square of something. 4 is 2 squared, so the very first term is like 2st squared minus 9u squared is, well, 9 is 3 squared, so it's 3u squared. Then once you have it as squared minus squared, you see that a is 2st and 3u is b. So now we can apply this formula, which says it should be a minus b, which is 2st minus b, not b, 3u, times 2st plus b, which is 3u. And that's it. That's the fully factored form. Again, please take time to expand this to check if it's a correct answer.